In this video, we are going to explore a few of RedScreen Expert's performance analysis tools using sub-daily data. We will look at a time series graph, a load duration curve, as well as a heat map. Along the way, we will also discuss some of the benefits as well as limitations to working with sub-daily data in RedScreen. Now, in RedScreen, we can move over to our data tab and we can see that we have imported our hourly electricity data from an Excel sheet. So now what we're going to do is we're going to move over to our analytics tab and we're going to do some performance analytics on this data. Some of the opportunities that are presented with sub-daily data is you will have the ability to investigate the relationship between multiple parameters. For example, you can display gas or electricity data as well as weather over time using a time series graph, as we will demonstrate. So in order to create a time series graph, what we're going to do is we're going to move over to step 1, dashboard. We're going to click graph and we're going to make our way down to the time series graph options. In RedScreen, there's 3 options for a time series graph. There is the simple time series graph, which will display all of your data. There's a 7-day or weekly time series graph, as well as a 1-day or 24-hour graph. In this example, we're going to look at the 7-day as well as 24-hour period, just because a time series graph on hourly data over an entire year or 2-year span is a lot of data and may become overwhelming to view. So we're going to start with a 7-day weekly time series graph. So we'll click 7-day. We'll have our graph here. We can name it, so we'll leave it at time series weekly because that is informative. We have our data table, so we have our electricity consumption table. We have the data we want to analyze is our electricity data. We have our increment, which is our period, so we want to select the right data we have here. So we have our hourly data, so we're going to click hour. Now we want to select our first day of the week, and I'm going to change that to a Monday, but that choice is up to you. Now the number of weeks we want to display, we have the option to display 1, 2, 3, 4, or 8. For now, I'm going to stick with 1 week period just to see what's going on in my building. The last option we want to pick here is the show on graph function. So here we can display our average, our peak, or both. I'm going to select both just because that may be informative for our purposes here. You also have the ability to customize the colors here, but for now I'll leave this as is. Now the last step before we're going to click OK is we are going to select whether we want to choose a factor of influence to also display on this graph. So if you wanted to display your electricity consumption against weather or any other parameter here, you could select that here. If, for example, you were displaying or analyzing photovoltaic data, you could bring in that data here to display against your electricity production in that case versus the solar radiation. But for now, I am just going to select the simple time series graph. I'm going to analyze my electricity consumption over a 1-week period. So now here you can see RedScreen has taken the most recent period of data we have here. So if I wanted to display a full weeks of data, it appears here I only have Monday, Tuesday, Wednesday. I can simply hit the previous period button and it will show me the previous week's period. So now what we can see here on the graph is I have my line, the blue line here that is fluctuating up and down. That is my electricity consumption. We have the average, which is the dashed line, as well as our peak. Our peak may be handy just to see when in the day we are using our most consumption, and then the average is handy also just to see your average consumption on a daily basis or an hourly basis. So some of the things we can take out of this graph here is you could perhaps identify shutdowns and startups for certain systems in your building, which may lead to opportunities to reduce your energy consumption. As well, we can also see what our base load in the evening would be, but if we truly want to see that, the best way may be to create a daily time series graph, which is what we're going to do next. So now if I go up to my graph function again under step 1, I can select my time series again, and I can select the daily time series graph here. So I'm going to select daily. I'm going to go through the same procedure I just went. So I'm going to make sure I'm pulling in my electricity consumption, my electricity data, my period, which is my 1 hour data, as So number of days, maybe instead of displaying 1 day, I'll display 2 days. And I'm going to show on my graph, I'm going to show my average and peak as well, the same as I did last time. So now I can select OK, and now I will produce a daily time series graph for 2 days. So again, I could, if this is not complete data, we'll notice here that our daily data ends at about 4. So I can go to the previous period, previous 2 days, just so I have complete data. So now I do have the ability to potentially see my base load as well as my peaks throughout the day. So let's say this day was my highest peak in this period that I'm analyzing. I do have the ability now with this handy little tool in RedScreen to add this day to our favorites function. So now we can then come back to this day quickly to see what is going on in this day. So if I click add, that is now selected as my favorite period, so I can navigate that to quite quickly. It is worth mentioning at this point that there is a few limitations to analyzing sub-daily data in RedScreen. The first that should be noted is that if there is a latency in your system, then you may not need to use sub-daily data in your analysis. For example, there can be a latency between hourly gas consumption as well as outside air temperature or production. So be careful when doing that, and you may need to filter your data to week or month in that case. The next limitation in RedScreen is missing data. And the way to get around this is to be careful during your data collection period and make sure you have no missing data before you get to the analytics point in RedScreen. Now, the last thing we want to mention about the limitations of sub-daily data is large volumes of data. As I mentioned earlier, the overall time series graph could sometimes be overwhelming and not too informative with a large volumes of data. So to get past this, we can use other graphs like the load duration curve as well as the heat map. So in order to create a load duration curve in RedScreen, we are going to go back up under step 1 under the dashboard, and we are going to go down right to the bottom, the final selection, which is our duration curve. So once we have our load duration curve dialog box open, we want to set a few parameters before creating our load duration curve. So we have our data table, which is our electricity consumption. We want to make sure we have the right table. We have our electricity data. We do not have our power data in this case, so we're not going to analyze versus power. We want to stick to our electricity data. Now our time increment, we have 1 hour data. So we want to make sure we change that to the right specifier for your data, which in our case is 1 hour. Now we're going to display this as a percentage. I'm not going to change it to hours. And I'm going to leave the marker as the default here. Now we do have the option under advanced if we want to run our load duration curve for specific operating hours within our building. We do have the ability to set those operating hours for, say, Monday to Friday if this was an office building. For now, I'm going to leave it as all the time just to display it on the graph. Now we can also display this calendar year versus fiscal year. We will go for calendar year as well as the last year or multiple years. In this case, we're just going to do the last year. Now, the last thing we want to look at is our thresholds. So this is a guideline, is one of the benefits of using a load duration curve. A load duration curve allows you to potentially identify your peak as well as your base. So those are the two main ones we want to look at here. So I'm actually going to turn on my peak and I'm going to leave it at 80% for now. I do have the ability to come back and change that later if I decide that that's not where I want my peak load to be, as well as my base load at 30%. So for now, I'm going to click OK and we'll generate our graph. So we can see here that we have our load duration curve and we have our red line here up at the top. So this is our peak load. So anything above this is our peak electricity consumption for how much percentage of the time it's on. And we can notice that our actual peak 1 hour electricity consumption actually runs for very little of the time. So we can see that in the graph as well as in our table below. So we can see anything above 80% of our 1 hour electricity consumption only runs for about, if you add up these numbers, about 2% of the time. So it's very small. So we can also see that our base load, it at 30% of the time, that accounts for the majority of our electricity consumption. Now, if we were to determine that our base load was not at 30% of the time, I could go back and right click on my duration curve. I want to hit my format graph to change things in our graph. So I've decided my peak load above 80%, that appears right. So now I want my base load, I'm going to actually lower that to 20%. I've determined that my base load is actually 20%, so I can change that to move that line down there as well. So now that we've explored our load duration curve, we're going to now explore what we call a heat map. And a heat map is kind of like the title describes. It allows you to identify areas of increased energy usage, or the hotter the energy usage is in that moment. So in order to create that graph, we want to go under graph, and we're going to go right to the heat map option that's second from the bottom here. So on our heat map dialog, we want to make sure we get the right data we want to look at here. So we want to look at our data table is electricity consumption. Our data is our electricity usage. We do not have our power data like we mentioned before. Now, again, we have our hourly data, not 15-minute or 30-minute. So we want to actually look at this first on a daily basis, but we do have the option to work at it on a weekly basis. So now we want to set our begin period. So we want to make sure we actually get a period where we have a complete set of data. So I'm going to change this to the beginning of our data, which is April 4th, 2021, which I believe is a Sunday, and red screen tells me that there. So I'm going to do 1 year of data. You do have the option to do weeks or months, but for now I'm going to go with 1 year. And I'll stick with the horizontal orientation, but you do have the option to flip it vertically as well. Now in terms of the color, I prefer a 3-color gradient, but you do have options to customize that as well. So I can see here my areas of low energy consumption will be in blue, and the high energy consumption will be in red, and the areas in between or average will be in yellow. So now once I've done that, I can click OK. So we can see our heat map here, which may seem a bit overwhelming at first, but if you look at what's going on here, so each row and the horizontal row on this represents 1 full day in the period, and then each of the individual blocks on the vertical axis represents each hour within the day. So we can see here that in the periods of about June, July, and August, between about 2 and about 8 in the evening, we have our highest energy consumption. So that may be indicative of a larger cooling load in this building. So that's how this graph can be handy to quickly identify areas or times of the year and times of the day in the building when your energy usage may be high, which can give you opportunities to possibly reduce that. But let's say we did not want to look at this on a daily basis. We can go back and format this graph. So if we right click on our title, we can format the graph, and instead of working on a daily period, I could look at a weekly period as well. So I can click week, click OK, and now we see a little bit different graph, but still identifies the same data as we did before, just displayed a bit differently. So with all of these graphs, if you wanted to export this data, you do have the ability. So let's go back to our time series graph, for example. I could click export all data, and that will allow me to bring out an Excel file with all of this data in it. The same option is available in our load duration curve as well as our heat map here. So a handy little tool if you need to pull your data out and display it in Excel.